All right, so we're going to begin section 4.2 talking about exponential functions. And in the first section of chapter 4, we talked about inverse functions and we talked about one-to-one functions. And now we're going to get into exponential functions. And so there's some properties, some basic exponent properties that you need to be aware of before we move into this in further detail. And so most of these are going to make pretty good sense when you think about it. When you see an example, you're going to say, oh, okay, yeah, that makes some sense. So the first one is that a to the x power is a unique real number for all real numbers x. So take some number, raise it to a power, that is a unique real number for any value of x. Again, pretty simple, not a lot to that. The next one is one of the key properties we're going to use as we look at examples through this section, and it says that some number raised to the b power is equal to that same number raised to the c power if and only if, this IFF means if and only if, b is equal to c. So what that also means is that if b is equal to c, that guarantees that a to that power has to be equal, a to the b power has to be equal to c to the a to the c power. So an example of that would be if you said, for example, 2 to the third power is the same as 2 to the 2 plus 1 power. Well, we know that 2 plus 1 and 3 are the same, and so since that's the case, those two statements are equal. Again, we're going to use that quite a bit in our first few examples. The next property says that if a is bigger than 1, so let's say a is 2, and m is less than n, so maybe m is 2 and n is 3, then it says that a to the m power is less than a to the n power. And again, you know that makes some sense probably, because 2 times 2 is smaller than 2 times 2 times 2, right? 3 times. And so that's what that one says. And then the last one here says that if a is between 0 and 1, so let's say 1/2, for example, and again, m is less than n, so we'll say m is 2 and n is 3, then it must be true that 1/2 squared is bigger than 1/2 cubed. And again, that should make some sense. I hope you know that when you multiply fractions together that are between 0 and 1, every time you multiply them, they get smaller. And so 1/2 times 1/2 is a fourth. 1/2 times 1/2 times 1/2 is an eighth. Obviously, we know that an eighth is smaller than a fourth. And so the reason that happens is because when you're taking, in this case, half of a half is a fourth. Well, when you do half of a half of a half, well, then it's getting smaller. It's getting, in this case, down to an eighth. And so those properties are all going to be beneficial to us as we begin looking at examples throughout this section. So with that in mind, let's look at these first few examples. So first one says, for f of x equals 4x, 4 to the x, 4 to the x, find each of the following. So the first one is to find f of negative 2. Well, we know that to find f of negative 2, we're going to take negative 2 and put it in place of x. So it's 4 to the negative second power. Well, based on exponent rules that we've learned before, we know how to simplify this. And so this 4 to the negative second can be written as a positive exponent by putting it under 1. So a lot of times when I teach this, what I encourage my students to do is think about this as being a fraction, where this 4 to the negative second is on top of the fraction. And to make that exponent be positive, we simply move that base and exponent to the bottom. And so when we do, there's a 1 left on top, and now 4 to the positive second on the bottom. And 4 to the second we know is 16, so it's 1 over 16. And so there's that answer. Hopefully that's something you're going to be able to do without a whole lot of issues. As we move forward through this, you're going to need to be able to know how to deal with negative exponents. If you're unsure about that, where you're finding this video on YouTube, I have some other videos for other classes where we go into exponent rules, and so you can kind of search through those. And I believe they're in my beginning algebra class, chapter 5, sections 5.1 and 5.2. So if you want to go through and find those to refresh your memory on exponent rules, you can. We talk about negative exponents in those videos, so that could be a resource that's helpful to you. Now, on the next one, we're going to find f of 5. So it means we're going to take 4 and raise it to the 5th power. And so when we do, you're going to see that that's going to be 1024. So you may need to use a calculator to do that. It is 4 times 4 times 4 times 4 times 4, 5 times. Okay, so just multiply that out, and hopefully you should be able to get that number. And there's not a lot to do with that one. That's just simplifying that exponential expression. If you have any questions about either of these, make sure you let me know. Now, exponential equations. As we solve these equations, we are, again, trying to solve for x. And so we need to get what we have on the right-hand side to end up being 5 to a power. Because if we can use this rule where that base to the b power is equal to that base to the c power, if we can get b and c to be the same, to be equal, then that's going to be helpful. But we got to get the base to be the same first. So what I'm going to do here is, as we look at this equation, I'm going to rewrite it as 5 to the x power over 1 to the 5 cubed. 1 over 5 cubed. Now, the reason I do that is because I need the base on the right-hand side to be a 5. That way, I can hopefully get my equation be 5 to a power equals 5 to a power. And so I'm on the right track, because now this 125 is 5 cubed. But it's on the bottom of this fraction. I need it to be on the top. So just like we talked about in the last problem, we can take this base and exponent and we can send it to the top. And when we do, it's going to change the sign of the exponent, but it is going to give us 5 to a power, which is what we want here. And so when we do, we're going to have 5 to the x power equals 5 to the negative 3rd power. Well, and now based on that second exponent property, if 5 to the x power is equal to 5 to the negative 3rd power, well, that must mean that x is equal to negative 3. And there's nothing to solve that is our value of x. Now, what if you want to check this? If you want to check it, take that negative 3, put it back in for x, and you can punch in your calculator 5 to the negative 3rd power, and it's going to tell you it's 1 over 125. And so you could easily check this without a lot of issues. If you have questions about that one, let me know. Now, what about this one? Sort of similar. But, again, we need this 3 to be the base. Well, we hopefully know that 81 is 3 to the 4th power. So if you rewrite this as 1/3 to the x power equals 3 to the 4th power, well, now we're getting close. We're getting that 3 to be our base. And there's an exponent rule that says that if you have a fraction raised to a power, if you flip what's inside this parentheses, that's going to change the exponent sign. So the sign of this number will change. Well, if we do that here, that would give us 3 as the base, which is good. That's what we want. And so if you flip that fraction and make it 3 over 1 or just 3, well, now it's to the negative x power. And then we're going to have 3 to the 4th. And then this negative x and 4 now have to be the same. And so it's negative x equals 4, and then we can solve for x by simply dividing by negative 1. And when you do, you get x is equal to negative 4. And so there is the final answer on that one. Again, if you have questions about that, let me know. Our key here is trying to get our base to be the same. That way we can say, well, our exponents also have to be the same. Now, we can do the same thing on this equation. You hopefully know that 8, if you were to break it down into its prime factors, it's 2 times 2 times 2, or 2 to the third power. And so we can take this 2 to the x plus 4 power and set it equal to this 8, which is 2 cubed, to the x minus 6 power. Well, now we have our base of 2. And again, one of our exponent rules says that if we take a power and raise it to another power, like this 3 raised to the x minus 6 power, then we multiply those exponents. And so, since our base is 2, this means that x plus 4 has to be equal to 3 times x minus 6. Again, when we raise a power to another power, you multiply exponents. Well, now we just have a linear equation that we can solve, and so we'll distribute the 3, and we'll have x plus 4 equals 3x minus 18, and then you just solve for x, so we'll subtract x, and we'll get 4 is equal to 2x minus 18, and then we'll add 18, and 4 plus 18 is going to be 22, and that's equal to 2x, and we'll divide by 2. And so we find out that x is equal to 11. And so again, not a lot to it if you know how to get that base of 8 to be a base of 2, and it's just changing that to 2 cubed, still raising that to the x minus 6 power. If you have any questions about that one, again, please let me know. Now, on this last one, I want you to try this one on your own. So I'll give you about 3 seconds to pause the video. So hopefully you pause the video and now we can work through it. And so we're trying to get 3 and 9 to be the same base. Well, we can make 9 be a base of 3, right? Because it's 3 squared. And so if we take this 3 to the x plus 1 power, and it's equal to now this 9, which is 3 squared, to the x minus 3 power. Well, now since our base is 3 in both of these, we can say their exponents are equal. So x plus 1 must be equal to 2 times x minus 3. Again, because a power raised to another power, so this power raised to this power, means we're going to multiply exponents. And so we can then take the 2 and distribute, and we'll have x plus 1 is equal to 2x minus 6. And then again, we're just going to solve for x. So we'll subtract x. We'll get 1 is equal to x minus 6, and we'll add 6. And we get 7 is equal to x. Now, on each of these, you should be able to check these. If you take the 7 and put it back in for both x's, on the left-hand side, you should have an equation that's true, and on the right-hand side, you should have an equation that's true. I mean, when you put them together. So, put 7 in for this x, put 7 in for this x, and both sides should be the same number. And so, hopefully, it does give you a true equation if you were to check that. In this case, just to show you real quickly, if you take 3 to the 7 plus 1 power, and that's equal to 9 to the 7 minus 3 power. Well, the 7 plus 1 is 8, so it's 3 to the 8th. 9 is going to be to the 4th power. Well, 3 times 3 times 3, 8 times is the same thing as 9 to the 4th. Again, if you put this with the same base, 9 being 3 squared, to the 4th, well, the 2 times 4 is that 8. And so this one does work out. I don't know what 3 to the 8th power is off the top of my head. I don't know what 9 to the 4th power is off the top of my head. You could punch that in your calculator and see those two numbers are the same. So that is a way that you can check these. If you want to check it, by all means, feel free to do so. This does wrap up this video. We'll continue in section 4.2 and get into logarithmic functions in just a little bit.